Let's get started. Hi, everyone. My name is Mo Islam, CEO of Tectonic's parent company, Archaea Media Group, and your host for today. Welcome to our webinar. For those of you who don't know Tectonic, we're a leading news media brand focused on the future of defense technology. You can check us out at www.tectonicdefense.com if you haven't already done so. We've got a fantastic conversation lined up with two amazing leaders who are shaping the future of US manufacturing, and we're going to explore a pretty big question today, which is how can agentic manufacturing, which is where humans and intelligent software agents work side by side, finally make American production both economically viable and globally competitive? For decades, offshoring won out because of labor costs, but that model has left the U.S. quite fragile, particularly to long supply chains, talent gaps, and slow responses to any type of shocks to the system. Now with AI and automation maturing, there's a chance to really change things. So factories built around intelligent agents can cut cycle times, increase throughput, empower frontline teams, and adapt in real time, turning what was an old cost disadvantage into an onshore advantage. We're going to break that down today and much more with the people building it. So Karan Talati, CEO and co-founder of First Resonance, and Rob Bukowski, VP of External Manufacturing at Hadrian. A big thank you to First Resonance for partnering with us on this conversation today. We'll run the conversation for about 45 minutes, and then we'll leave about 10 to 15 minutes at the end for your questions. So please drop them into the chat, which you'll see at the very bottom of your screen as we go. And feel free, if you guys have any questions like during the arc of the conversation, I'm happy to see if I can kind of squeeze them in so we don't necessarily leave all of it to the end. So feel free to drop those into the chat. With that, let's get started. Gentlemen, if you don't mind, just give us a quick 2-minute background on yourself and your company. And Karan, why don't we start with you?
Great. Hi, everybody. Mo, thanks for having us on. Great to be here and to be talking with both of you guys today. I'm Karan Talati, CEO and co-founder of First Resonance. At First Resonance, we are building the leading factory operating system, powering over 50 companies now across aerospace, energy, robotics, heavy machinery, and quality critical industries such as our team's background comes from aerospace and these types of quality critical workflows. And I'll save a little bit about how we've been powering companies with digital technology to power their factories. And now that's leading into more of an AI-driven workflow, really simplifying a lot of the overhead that used to come with setting up digital technologies.
Rob, over to you.
Yeah, cool. Also very happy to be here. My name is Rob Bukowski. I'm VP of Manufacturing Services at Hadrian Automation. What we do at Hadrian is we build AI-enabled smart factories in the aerospace and defense sector. So we have a just under 100,000 square foot facility factory in Los Angeles. By the end of this year, we'll actually have a facility that's around 3 to 4 times as large in Arizona, which is very exciting. Generally, the mission of Hadrian is to reindustrialize America. Prior to Hadrian, I was co-founder and CEO of a company called Datum Source, which Hadrian actually acquired a little over a year ago. What we did at Datum was we built software and tech-enabled services to help with the procurement workflow for space and defense companies. Prior to that, led supply chain at Virgin Hyperloop, and then prior to that, had various different supply chain management roles over at SpaceX.
Got it. Okay. Well, let's kick things off. Rob, I'm going to start with you. And then Karan, obviously, and vice versa, feel in to chime in whenever you guys have anything to say and also interrupt me. But Rob, just to kind of get things started, give us the quick arc, right? From the 70s to today, why the US offshored, what structurally changed that makes reshoring viable only if factories are quote unquote smart. And I know you're CEO, their CEO of Hadrian, Chris, talks about this a lot. And he does so with a lot of emotion. So would love to hear your perspective on this question, just as we kind of kick things off.
Yeah, no one can quite give this history lesson as well as Chris, but I'll do my I'll do my best. But and excuse my my voice here, just getting over a cold. But the foundational element really of a nation to be a superpower is that you have to be dominant in heavy industry. The reason for that is that allows you to have a superior military. Once you're in that position, then you have the ability to have all the other value streams that come with that, right? And so the U.S. had this World War I, World War II, But starting around in the 1970s, and obviously I'm summarizing and just going quickly here, but that's when the US really started to offshore a lot of manufacturing to Asia, most specifically China. The reason for doing that, as you mentioned, in the most summarized way, is that there is lower cost of labor there, which transitioned into lower cost of goods sold, which meant more people can have more stuff for less money. There's also some arguments in there that it helps to lower the amount of inflation in the country by offshoring labor. So there are some benefits that you will find that are out there. My personal take is that ended up, in retrospect, being a major mistake, even with the benefits. And the reason for that is that you now have China as the world superpower of manufacturing. Some stats behind that is, China has a bit over 3 million factories, where the US is closer to around 250,000. I think even more importantly is that the average age of, say, like a technician in the space and defense world in the US, or like a shop owner, you can look this up, but their ages are going to be high 50s to early 60s. So what we did is we really skipped generations of getting into manufacturing, partially because it made economic sense in the immediate to offshore. Also, we did a really bad job within the US of branding the really good things about manufacturing. We kind of labeled it as not being very glamorous. And so you have all these, generation or two that just didn't really learn any of the skill set. And so now we're in a position where you can't just say, okay, I'm making this thing in Asia, I now want to make it in the United States. It's not that simple, because the United States currently doesn't have the digital or physical infrastructure to be competitive in every angle. So that's kind of the bad, if you will. The good of also where we're at is that it's not like the United States was just sitting on our hands since the 1970s, right? We have become very superior in other things. Software, finance, I'd argue AI. And so those are the key blocks you really need, and things we'll talk on today, to actually reestablish dominance in that sector. And so I think with the correct priorities and the smartest people working on this, it's a very challenging, but challenging thing to actually pull off, but something that is certainly possible.
Well, let's actually talk about the challenges for a second. And this is a question for you both, but maybe Karan, we can start with you, which is like, onshoring, reshoring. This is a huge, huge theme. I mean, there's large conferences now that are devoted to the reindustrialization of America, right? What are the challenges to meeting these objectives that everyone's talking about?
Yeah, like I'll throw something in here. Just building off of what Rob said, just taking a step back. I mean, super interesting kind of evolution just in the last few decades. I think a fun statistic for everyone is, just in 2001, the average cost of labor in China was 60 cents. Today, it's $6 an hour. So that's a 10x increase, right? So all of a sudden, in just the last 20 years, everything theoretically will be 10x more expensive. So even China is changing around its industrial kind of efforts. And of course, the pandemic accelerated a lot of the cracks that were already there. So here we are. And Mo, the question that you asked about the challenges, I think Rob hit it on the head. We basically skipped generations, right? We are a military superpower. We do have a lot of great things, from history, as well as the advancements in technology. However, certain things where you need the technology to actually kind of mix together, right? So how does software come up with industrial technology and thereby enabling an industrial sector? That's kind of missed. You look at a lot of factories out there today. Machines are absolutely disconnected. People don't even know what's going on. And for a lot of people, this is surprising, right? Because the same companies that are maybe even highlighting and showing how technologically advanced they are with digital systems, and how they're using generative design or advanced CAD and things like that. These are only in snapshots. When you walk out onto the factory floor, you'll find a lot of paper being passed around. You'll find a lot of people who don't know what the highest priority job is. And the reality is, even culturally, we haven't really adapted to what does agility look like and what does it need to be in the factory to meet these demands. right? So you'll find a lot of people saying things like, well, this is how we've always done it. And that knowledge, and Rob touched on this earlier as well. It's it's a lot of tribal knowledge, and entire factories are one retirement away from Seth, the machining guy, that knows all the how you got to hit the machine a certain way to meet the tolerance for most of the jobs that come in. And that's terrible, and we're already seeing factories shutting down because these people are leaving the workforce.
So I want to touch on this point of how we've always been doing things. Maybe, and this is a question for you both. Like, what are the kind of mental models that you hear from executives evaluating reshoring that are incorrect or that you feel are just looking at things the wrong way that you've seen that you've noticed?
Yeah, I can start. I mean, I think there's probably two main things I see. The first one's probably the obvious one that people probably look at the most, which is looking at not really considering the fully landed cost versus just looking at the unit costs of it. The one that's probably more interesting to talk about that I've seen a good amount of is that obviously a lot of executives have been working at that company or in the industry for a long time, and things are changing very rapidly. And I think that the issue that I've seen is that executives often have this mentality of what got us here will get us there, and that really isn't always the case right now, because Karan brought up an amazing point, which is a lot of shops have single points of failure. All right, they have a certain person that's kind of holding a lot of things together. That person retires, it no longer becomes a very good partner. And so what I think this leads to is that there's a lack of sometimes, not number one, but there can be a lack of interest in working with certain companies that might not have that like immediate maturity you're looking for, and might seem like too much of a risk for the executive to partner with and develop with that company. I have seen firsthand, with Hadrian, fortunately we're on the other side of that now. And we got there because, a lot of executives came in and did see, oh, wow, this is the future. They might not be as mature as some other partners at that point, but they saw that heads are on in the right direction and the technology is in the right place. And so it's like, let's partner and get them up to speed. And now everyone's benefiting from that, right? And so I think that hesitancy of working with companies that maybe aren't at the optically maturity level that you're looking for, I see that as a something that I hope gets corrected.
Yeah, I'd love to just piggyback off of that. That's exactly what I was thinking about, Rob. Even for what we see and what we encounter, I think, yeah, it's this distrust or lack of confidence that technology, first of all, is necessary. I think there's no doubt. I mean, I just talked about some of the statistics about relative labor in China. So even at an average of $6 an hour in China, I mean, labor rates are much higher here. So how are you going to close that gap? It's not just going to be through wishful thinking and geopolitical effects and tariffs alone that are going to be helpful in closing the gap. And we have this amazing thing that's sitting right here, which is software, technology, ingenuity, creativity, a great thriving capitalistic economy. But sometimes we do see manufacturing executives, and I think it's a combination. I don't blame them fully either. Sometimes they feel left out or that the technology is not for them. That tech is really meant to serve more of the services, consumer type of workflow. But these same things that have benefited the consumer and services side, these are technologies that are ready and have matured and can actually meet the industrial scale. So I think that's definitely one sentiment. I agree with you, Rob, on that. Another one that I think is a little bit counterintuitive is technology hasn't fully served manufacturers over the last few decades. However, there have been a lot of promises. So you look at manufacturing tech, you hear terms like industrial IoT or Industry 4.0. And again, you go back to all these like videos of these futuristic factories where everybody has AR goggles and are moving CAD models through machines, and all the machines are streaming out data, right? A lot of people rightfully are saying, where is that? Like, where is that promise from the industrial tech sector? Why isn't my factory lit up? I've never seen a factory like that. And like I said, I think they would be right because it is such a heavy lift to bring these technologies up. I think a lot of that now has rapidly started to change as a function of newer technology being able to handle much more multimodal data input, so voice, images, and also unstructured data, which at the end of the day, when you think about a factory, that's exactly what a factory looks like. It's more sounds, images, and voice than it is clicks and forms. And you know, it's a lot fewer AR goggles that are moving parts and driving value, and it's much more, you know, CNC machines and you know, welding stations and 3D printers even.
So let's talk about sort of the main topic at hand today, which is agentic manufacturing. And maybe Karan, why don't we start with like the what is it, like definition, and then how is it different from like the classic automation or the Industry 4.0 dashboards that everyone's been talking about, and why do you feel like it's actually coming versus something that we're just all going to talk about today and then we may not actually see deployed in factories?
Yeah, absolutely. So we're really excited about this. We have at First Resonance been talking about agentic manufacturing a lot more in 2025, but really only started talking about this seriously in 2025. So taking a quick step back and without nerding out too much, this world has moved so quickly in AI. 2023, you know, the entire world had its chat GPT moment. You know, we got this magic of an individual text box being able to answer any question. Back in 2023, that was sometimes right? Those models really progressed in 2024. And just in 2025, we've gone beyond just LLMs, so these large language models that can answer questions and have a lot of information, into actually connecting these LLMs up for actual tasks. So new concepts around tool usage and taking actions for affecting data, moving parts, moving things have only become possible recently. So agentic manufacturing is leveraging the advancements in AI to power real world applications, particularly in manufacturing. You know, I could definitely talk about some of those use cases. We're still pretty early, I would say, from this being a well-known type of topic. But another way to think about this as well, and think about agentic manufacturing, is really teaming up between human decision making, human creativity, and these AI agents that are working around the clock, working to you know, either complete the first mile types of activities, so just things like data aggregation and data input, which you know, including in the most advanced manufacturing facilities, takes up a large amount of human time today, right? Especially in quality critical industries. So a way of thinking about agentic manufacturing is manufacturing in the context of putting the best of what humans have to offer, as well as what AI agents have to offer, and offloading the right work on one another to get all that done much more efficiently, much faster, and with better quality outcomes.
So, Karan, have you guys deployed any agentic workflows yet?
We're in the very earliest stages of this. So, in just about a month and a half ago, we announced Ion Intelligence, which is our agentic manufacturing platform, bringing these AI agents into the factory. And actually, just now in August 2025, we're starting to work with our very early beta customers. We do have internal developments here where we've been testing these AI agents using synthetic data in manufacturing. So I'll give like a few examples. We've shown that we're able to take simple kind of open source drawing files, so two-dimensional drawing files that many listeners will be familiar with, feed that to an AI agent to get feedback actually. And this is important. You want to use AI not to fully automate large chunks of work, but rather discrete chunks of work that are pretty well understood, but would take otherwise a long time, right, to do manually. So just getting things like drawing feedback loops, getting things like mapping 2D drawings into manufacturing work instructions, we've been able to show these LLMs are quite proficient at. But actually, one thing I'll also add is we've seen that they're only about 70 to 80% complete. The good news is they can accelerate, you know, the end to end here by like 3-4x. So a company can move 3 to 4x faster, but a human has to augment the AI in order to get the work out and done with quality.
Rob, maybe you can chime in here a little bit. How do those systems, from your perspective, help with the complexity of customer requirements?
Yeah, I mean that specific angle of what we're talking on is one of my favorite things to talk about, just because I'm very excited about the outcomes of what that's going to bring. Obviously, I have a very kind of biased supply chain perspective, but to kind of paint it in more of a maybe a simplistic way of, if you were to build, let's just say, a couple unique part numbers for an aerospace prime, you may very well, like, it would be very common to receive 100 plus PDF PO document to kick that work off, right? Just for a couple part numbers. And the reason for that is because, as I'm sure a lot of people assume and know, there are a ton of requirements in aerospace manufacturing. I don't know if people know the extent to how many requirements there actually are, though, right? And that's why that document is like 100 plus pages. And so when you look at it, when you look at the requirements, I'm talking things like every part you're working on has a multitude of quality clauses. There's a multitude of specifications. There are certain terms and conditions you need to follow, sometimes multiple. There are all sorts of government regulations or compliance requirements within that purchase order, right? You have FAR, DPAS, ITAR, DFARS. I could list acronyms all day long, but they actually do all matter, right? And so all of these different requirements in that document that are called out, each of those, when you go and you look at it and say, what is this requirement? Because it might say reference, DP 145 or whatever. You then have to go and find where that specification or that requirement is. That now is another huge document. And things within that are often defined by another requirement, right? And so it's kind of like you're on Wikipedia, just kind of clicking around, trying to really understand, what am I really truly expected to do here to be fully compliant? And so my point with all that is that it's very time consuming work, and it is also very sophisticated work. This isn't something that just anybody can do, right? It needs somebody who really understands everything that's going on. And so that sophisticated person needs to spend a lot of time to look at that order and really truly understand all the requirements. That's challenge one. Challenge two, which is even harder, is then making sure that all of the stakeholders within your business understand what they're specifically accountable for and responsible for those requirements. Very hard to do unless you have proper systems in place to be able to disperse that messaging and label those owners throughout the entire process of it. The third thing that you have to, third challenge, I think, is actually the hardest, which is you also have to make sure that the applicable requirements to any of your sub tiers are also understood and also enforced and followed. So if you have a coating supplier, let's just say for your part, there is a lot of specifications and requirements involved in that job that is on you, your responsibility to communicate well to that sub-tier supplier. And so there is a lot going on here as far as the ability to interpret and understand the data, and then also communicate it correctly and make sure it's understood, and then enforce it and then review it at the end. I'd argue that's one of the primary reasons why you have such fragmentation within the aerospace supply chain. There are other reasons, a very capital intensive business and yada, yada, but I think it is very hard, given that 85% of like machine shops, if you look at those, are under 20 people, to work with multiple customers who all have differing requirements and be able to take on a multitude of different programs and projects for each of those customers. It's just, without AI and like things that Hadrian is doing, I just don't see it as possible. And that's why you have a lot of that fragmentation. What we do, and what I'm very just tremendously excited on, is some people probably pieced together how you can use AI for this. It's a really fantastic use case of being able to train models to be able to read those requirements. They're not all the same between customers, but there are some similarities in how you can kind of model that out, and how you can parse that data and then be able to make sure that it feeds into the correct MES systems basically throughout your factory, and then your procurement execution systems to the supplier, and how you communicate that. So the ability to do that extremely faster, and I'd say actually more reliably, because you're not just purely focused on a human, you're talking about a human in the loop with those systems, makes it so you can do it much, much faster. And I think that's a huge game changer for the industry.
So I don't know if this is going to be one that you'll both agree on, or if there's like an obvious one out there, but like, what's a trade-off in manufacturing that we've accepted for decades that these systems can finally kill?
I mean, I think, for sure what Rob just said, one of these trade-offs is just that it is complex because it's quality critical. And that's true. But what's happened over time, right? And if you getting outside of technology and just zooming all the way back like a century, the amount of innovation and rapid iterations that led to the modern aerospace industry and defense industry that we're in today is like a really interesting way to look at it. I think like reading this book Skunk Works from, I think it was Ben Rich, right? Like
Favorite book.
the guy that took over the Skunk Works program, right? He was talking about just how iterative and flying by the seat of their pants there were. And what we did over decades, a lot of the reasons being the right reasons, is we added in a lot of safety protocols, quality protocols, regulation, again, for maybe good reasons, right? Quality and safety matter. However, it comes with a cost. And I think the trade-off there is that just because we want to build quality, critical, safe products does not mean that we need to eat that cost of the amount of manual work and just overhead that goes into it. And frankly, it's untenable, right? Timelines are moving too fast. The adversary, thinking about it from a defense perspective, the adversary is not moving with that same level of rigor and requirement, and that's a real threat. So I think this approach actually, it gets best of both worlds. You can move this stuff to compute, which is pretty exciting.
Yeah, I agree. So I'll keep it short. I mean, I think that the trade-off of quality versus speed is the one that is really going to change, which I'm very excited about. I think that we should mention that there are, and Kron did, but there's very good reason that these requirements are in place. I'm actually not arguing that we should not do a lot of what's going on here to some degree. I think that it's more just about like, when people talk about like, oh, anyone who just only works with primes are super slow suppliers. And when I first started the industry, that's just kind of what I assumed. It just worked that way. The reality is that they're slow because they're dealing with all of those different requirements. That's is one of the primary reasons for that, right? It's very challenging to build fast parts while being in full compliance with everything. And so we're just going to be able to have the opportunity to really speed that up. So I think you'll be able to see it does just become more of a game of who can, in machining sense, subtract metal in certain amount of time versus the several weeks of requirements and work that has to be done on the front end of that. So it's pretty exciting to not have that trade-off in the near future, hopefully here.
Well, so Karen, I'm glad you brought up Skunkworks. So, Ben Rich, Kelly Johnson built this like incredible team of multidisciplinary like folks who like came and built the program and built all those legendary aircraft. I'm curious, and then Rob, this is a question for you, like fast forward today, like does the US have a worker shortage, and is there sort of a generational kind of skills gap? And how do you guys at Hadrian think about sort of onboarding non-factory talent and making them productive quickly?
Yeah, I can start unless you want to comment on that. But
yeah, go for it.
All right, cool. 100%. I think that we do have a generational skills gap. I think that the data is just there for that. So I'd almost say it's not even up for debate. I think that I mentioned earlier, but I just think between offshoring and just we really did a very, very bad job of highlighting why manufacturing is cool and serious. And most of the shop owners that I know and talk to, their kids studied something else, right? And that's just one of the telling signs that I see a lot of, right? And that's fine. I'm not saying everyone needs to necessarily be in it, but I'm just saying that we really lost that kind of cool factor with manufacturing, and I think that contributed a lot. As far as what Hadrian does, I think it's one of the most compelling things that we're able to do is that we really accepted that constraint and challenge in the market. And so actually 100% of Hadrian's factory employees have not worked in a factory prior to working at Hadrian, which is crazy because we are very much so building very intense space and defense components every single day. And so we're able to do that because we have really great workforce development and we have really great AI automation technology. And so what it means is that when you look at legacy players in space and defense, kind of the T3 manufacturing world, you're typically looking at 5 to 10 years to train a really solid machinist, someone who could run like, let's say, $1 million piece of equipment on their own. we're able to do that in 3 to 6 months, and we have repetitively done it, and it's why we're opening up another very large factory, and you can kind of scale those operations. So I think that is just, if anything, of an optimistic piece of how we're able to solve that generational talent gap. I think it's seeing what what we're able to do in that training instance is really, really fantastic to see.
Yeah, absolutely. Deloitte put out a statistic, or it was in their Manufacturing Institute release, not exactly sure when. They talked about by 2033, we're going to need to fill 3.8 million manufacturing jobs, and 2.1 million of those jobs will be unfillable just by the projections of workforce development, who's coming out of universities and things like that. I think this is a very surface level statistic. I, like Rob, am a little bit more optimistic here. I think the good news is we definitely see the problem, right? I think people are not necessarily fully aware of just how stark these metrics are and what that could lead to, right? Of having 2 million jobs that are just unfilled. That being said, I look at what the software industry has looked like over the last 10, 15 years. And not every software developer in the United States comes from a computer science background or needs to have that deep level of university education. And there are multiple ways that people have upskilled and trained a workforce up on writing various levels of code, right? From junior engineering up to more senior levels of engineering. And it's almost this virtuous loop. And I see that starting to happen. I think we're very early in the physical world in manufacturing. But customers like the ones that we work with, and as Rob mentioned, it's I think Hadrian's been talking a lot about their investment into workforce development. We're seeing it in other areas. I am more optimistic that these jobs that need to be filled don't necessarily need to come from the same place that we expect them to, right? Come from. And I think, Mo, to your point earlier, this one, you talked about the multidisciplinary nature of the early kind of aerospace ascent in the 20th century. I think there's a big opportunity for that now as well, with so much interest in physical world manufacturing, hardware, and defense tech coming from Silicon Valley. Rapid 180-degree switch in the last, I would say, 3 to 4 years now creates this opportunity to apply pretty clever and pretty creative individuals at solving these problems. But I think we do have to close that gap, and there's no doubt there's a shortage today.
So, Rob, question for you. So, what are the changes in leadership? I mean, you're a leader at the company that you're exhibiting or you're doing yourself, or kind of that plus shop floor rituals that are making this empowerment of the frontline worker stick. Is there anything you can talk about that where you guys have stopped doing and one thing you've institutionalized, just on a more practical and in practice point?
Yeah, I mean, I think how I'd answer that is probably more looking at how we interact with the supply chains. That's more of my area of expertise, and so I can speak to that better. But I think that commonly what you see within procurement in aerospace and defense is that, given all the requirements, things we've been talking a lot about, what ends up happening is you kind of have this situation of people are really just prioritizing saving their own ass, covering their ass when they're trying to send out let's say a purchase order to a sub-tier. What I mean by that is that you have all these requirements from a customer. You need to flow down said requirements to your sub-tier supplier. The common way of how that's done is that you just send that purchase order and you wait for them to say, I acknowledge this order, right? That's part of the AS9100 and ISO, and everything is getting an acknowledgement. That's what I mean, where that's not actually, though, trying to give empowerment to the frontline workers and set them up for success. I think the better way of going about it is okay, what actually did I have here that needed to be done? What am I really trying to make sure I communicate and make sure is understood upfront with the supplier partner? And so what that looks like for us is just a small example can tell you about how we've kind of enforced that, is that through within our product, once we break down those requirements and we send it out, we don't just have one master, I'm good, I acknowledge this purchase order. It's, hey, here's how we've bucketed these requirements. Here's how we describe what they are, but make sure you read what they actually are. And let's have a discussion and walk through and do this so that we are all aligned and set up for success. I think that shows to the frontline workers within the supply chain that you're treating this seriously, that you're going to look out for every detail, and then they're going to treat it the same way. But it's also making sure it's saying, hey, we're partners in this and we're going to figure this out together, and here's what we have. And so I think just little processes that are actually looking at, okay, how do I actually help make something better versus like, how do I just legally cover myself and push off liability? End of the day, the customer really doesn't care who screwed up. They just cared someone screwed up. So I think it's better to have that mentality. And I think that's how we've kind of empowered our ecosystem of partners a lot is by doing that. And so I'd say that's one thing to highlight.
Got it. Okay, well, so I want to switch gears for a second and talk a little bit about, sorry guys, I want to make sure you guys can hear me okay. I think my AirPods went out. So I want to talk a little bit about this theme of like resilience by decentralization. So Karan, just to kind of start with you, like when a centralized system fails, it fails pretty loudly, right? How does an agentic system localize problems and then self-reroute, schedules or parameters, without sort of like, a centralized war room? Like, is there anything you can talk a little bit about that, sort of like how this decentralization creates resilience?
Yeah, absolutely. So I think it's a fantastic question, Mo. And even before the AI wave, at First Resonance, we believed in the importance of more flexible, more nimble systems. And frankly, since we started a lot of these old systems, we talked about the promise of one central repository of truth. Like people talk about this, and we've always discarded it because I think, you take some of these systems, whether they're in a factory, whether they're in the digital world, et cetera, you just make your projection in like governments. Like I think like many people on this call will probably agree that like very tops down centralized government isn't what we subscribe to, right? That a more thriving, competitive, and democratized economy and government is better. But there's an irony there, right? A lot of these systems that do support large operations like factories are very centralized. They are very large, and they become more and more sophisticated over time. That sophistication leads to a lot of fragility. I think Rob can definitely talk about where this has affected supply chains in the last 5 years, and how we've seen supply chains that were overly robust or whatever fall apart. But I think what's really exciting about these new patterns is they are a lot more flexible to build and get value out of. So you talk about an agent, right? This can be an agent for something as sophisticated and large as planning your entire factory schedule. Okay, that would be very large. Or you could have an agent that's just doing something like a quality, like it's kind of like a quality inspector in the loop that's making sure that the details are filled out for what the quality nonconformance was and the resolution, something pretty narrow. And maybe you could even zoom in more and say that this is a quality inspector for additive manufacturing only, where this agent is, just has a lot of context on additive manufacturing, material properties, and failure modes. And so it just rigorously inspects for that. Given that it's, pretty flexible to build these systems, it's pretty flexible then to operate these systems. And when other agents go out, right, that agent isn't overly dependent on a large system to orchestrate all this stuff. It's not one large code base where if something goes wrong in supply chain, that brings down the entire factory line. So in essence, because of the flexibility of these systems and maintaining these systems and the technology that's now here, it starts to look a lot more like what a kind of like marketplace economy looks like, where a factory is really just like a whole bunch of work centers that trade with one another and have their own kind of more resolute supply demand, as opposed to one large orchestrating beast where If there's just one bottleneck, the entire operation falls apart. So we're pretty excited about that. It's a lot more fun to be in those operations too, right? Because then the human can come in when there is a problem. The human can come in and make a clever decision about how things are going to reroute. And the AI system's actually flexible to that. You're not, redoing an entire code base or introducing a code change that's going to bring the factory down before turning the system back on.
So, Karan, you touched on this in just a second, but just maybe ask it a little bit more directly. Like, how do you think about these systems and then cyber threats, right? What are sort of the autonomy guardrails that keep it safe?
Yeah. So, look, I'm not going to claim to have the full answer here. The reality is that when it comes to safety, security in AI, these are pretty nascent fields that even, the big model players are, putting front and center in how they roll models out and provides for more of these actions, right? It's important to be aware of all these things. With semi-autonomous systems making decisions, you need to have the right guardrails. So I think the point that you brought up there, Mo, is good. Guardrails are very important here. The good news is, this technology now exists. The infrastructure is there. And, in the manufacturing world, you could just apply these guardrails out of the box. Things like human-in-the-loop decision-making systems, right? Other things where, even like entire permission patterns that will allow for automation in read operations, but always require human feedback for write operations, right? So that's really good that there's been such a huge emphasis, I think, from the AI community for these guardrails and security, where I think it's pretty clear, like people are even maybe holding back on what the potential of these systems are, so that we make sure to roll them out in a safe and compliant way. And I think one thing that serves really well in all this regard as well is trust is a big factor. So this is almost built in, I would say, especially in manufacturing, where it's very important for these semi-autonomous systems to, gain and then maintain a high degree of trust. All it takes is one incorrect automated decision for people to stop using a system. And so these systems and the people who are building these systems are almost cautious by default, knowing that a false positive here is very expensive, right? So I think that's great. I think like that, what that means for manufacturers is that the potential is actually a lot greater. Like the speed at which the technology is developed is already outpaced the deployment. Like we're being like everyone's being very cautious and taking a reserved approach at rolling these things out to make sure that we don't lose trust.
Awesome. So we're gonna turn it over to questions in just a second, but while I have you both here, why don't we like try and put together a playbook? So if I am if I run a US aerospace factory, I want this in like 90 to 180 days, right? What does that like? What does that look like? What is the sort of crawl, walk, run to get this implemented in my factory? How would you guys, if I hired you both as like my advisors, like what would you say?
I think that the right place to start with that, in my opinion, is to look and understand what are the software tools that you're going to need, and but you have to look at it, I think, first from perspective of there's a lot of people that want to open a shop because they're highly intelligent mechanical people. Let's just say I meet these all the time. They're wonderfully intelligent people, but they're really good at a certain skilled trade, and so they want to start a business with that trade. They start by buying the machines, they start machining, and then they figure out, oh, I need to add in software layers to become more efficient. I think the software layer needs to be, from the beginning, needs to be put in place right after you identified, okay, I am this person that knows how to work in this industry, that is just needed. There's ways to learn that. But then you need the ability to define, okay, what are the processes that I'm going to do to get a part from when I receive raw material to out the door, right? And then making sure then, do I have a software system that's able to help put the guide rails in to enforce that that process is being done and being done correctly? And then the second part of that software is, are there areas that I can input data so that the factory is constantly getting smarter after every single part that I'm building? Right. And so I'm speaking broadly because there's a variety of different manufacturing and things that would differ and small nuances between what you would do there. But in general, I think that is a kind of first principle step that is missed is trying to understand how do I have a software that's is synergistic with how the processes are going to happen within my company, and then making sure that I have the change management side to be able to fix things when they're not working, and to be able to constantly make the software smarter so that my factory, every single part I'm building is continuously getting smarter. And you don't have these kind of single points of failure that are just holding up everything.
Yeah, I think I'd layer onto that and just take one step back from what Rob mentioned, which is start with what you have. I think today, what's really exciting about especially these AI and agentic tools is they're really good at handling unstructured data, like I mentioned. And what's opening up a lot of opportunity, and we're seeing this everywhere, is factories who, you know, 5, 10 years ago were running on email and phone calls. These were not digital operations. All of a sudden, actually, email might be just fine. So taking a look at what existing operations are going on and looking for opportunities of double data entry, because what used to be, again, just 3 years ago, people used to email with suppliers back and forth, right? And Rob talked a lot about supply chain. Email suppliers back and forth, and then take that email and then put it into a digital system. So you know, these people were, you know, kind of glorified data entry people, even though the system they were putting into is like highly sophisticated. You can now close that with AI. And I think these are wonderful opportunities to just close that double data entry, because that, if that takes hours a week, you're talking about hundreds of dollars, and that, you know, from just one individual, that adds up to millions of dollars a year. So taking small bets is, I think, really good. Making sure that those are fault tolerant and able to be rolled back, right? Again, these are much more flexible systems. So, you know, just by practical example, just let's say there's like a story of a factory. They have a whole bunch of suppliers. They're emailing and calling those suppliers back and forth. Put in an AI agent to automatically read emails coming in from suppliers and input the latest ETAs into your centralized system, so you can make more data-driven decisions on how you're going to route things through your factory downstream, assuming you already have some of that. But again, it kind of, you might not have any of that, so I don't want to be overly prescriptive, right? It's all about finding those opportunities. But something as light as a fax or an email now is fair games for making a factory digital, which is super exciting. And then, you know, I would say is like take those small bets, make sure they're able to be rolled back, make sure that people don't get overly dependent, and if they break, the factory breaks, avoid that. But when things do work, give people a lot of focus. We've seen a lot of benefit in this following playbook, which is when you do get it right, give people who are really passionate about digitizing and making these factories much more efficient the full-time job of doing just that. You know, they're young, hungry people who are digital natives who just get this, and you know, they're not formally trained for this or anything like that, but given the right tools, you can invest in them deeper. And I think we've seen a lot of magic come out of that playbook. So when things work, invest.
So I have a question here, actually, that's along the lines of Karan, what you're talking about. What's the most common mistakes that you've seen or you predict leaders will make when trying to go digital in manufacturing?
Yeah, I'll just echo something I said earlier, which is, you know, counterintuitively, the more tech savvy actually manufacturers will sometimes overinvest and actually create a lot of complexity in how the system should work or what they've seen at a more scaled operation. This is one that I think Rob and I have both seen a lot, is like, oh, back at, you know, Acme Corp, we used to have these demand signals go over here that would automatically turn on this 3D printer and do this and that, and then they try to re-implement that in anywhere they go, right? And they overinvest in just the implementation time and setup there. So it's counterintuitive, right? Sometimes you got to keep things simple. I think especially as technologists, that's incumbent on us.
Rob, I think this question here, I'm going to direct this to you. How do you see factory jobs being marketed to the next generation? Like, what's the new pitch for attracting talent?
Yeah, no, that's a really interesting one. I think that I think that we have to really get back to the kind of roots of and again to kind of piggyback off of how Chris, our CEO, says this. I think he says it very well, which is that I think that we've gotten very unserious about our careers in a lot of regards, right? I think a lot of people look at certain logos and places to work, but the reality of what they're building, it is not incredibly serious.
You mean cat JPEGs aren't serious?
Maybe. And I think that we've kind of lost trace of that, right? Like it's almost like we've been living and thinking that serious things aren't needed anymore, that we're okay without them, and that's not really the case. And it's not a level of fear by any means. I think it's more a level of like instilling pride, right? It's about saying like, what you're going to be doing here is very serious. It's very needed. It's going to be very challenging. And I think that we'll be pleasantly surprised at the number of people that really step up and want to take on that challenge and want to be part of that. And I think that a lot of what's lacking in the world, and I'd say a lot of this is, people are oftentimes working not with their teams. They're, not really don't feel as much a part of it. With manufacturing, like, you have to be there. I'm traveling, otherwise I'm always at the factory, right? Like you have to be there and you have to be part of that team. And that I think is a very key thing that you will get places. I mean, you go walk around SpaceX and I bet 70% of the employees are wearing SpaceX swag, right? That's a very unique thing. And I think a lot of that of what ties that in is that level of pride is that everyone knows they're working on something that's very serious and very challenging. And they, put their identity towards that a lot, which I think is a really good thing. And I think that any type of manufacturing has the ability to do that and to instill that pride.
Can I add to that? I love that. I'm also pretty passionate about this. So, some of the statistics around the 2.1 million jobs that we have to close the gap of that I shared earlier. If we do close that gap, the same statistic goes on to talk about how 75% of the workforce will have to be millennial or Gen Z. Most of this has to do with the replacement of a lot of the former generations. That's actually like a huge chunk, literally people who are not going to be alive or definitely retired are going to have to be replaced. So I think there's something interesting that's still unexplored here. I do think that blending, what has caught people's attention in the last 10, 15 years is very important. I think Hadrian is doing a lot of this, right? Young people are getting very excited about it. I think there are other companies. I think like companies like Astranis are very like invested in their social media presence. And it's like, it's very serious, but it grabs attention and I think they make it very appealing for young people. They also have these like meme t-shirts, I think that they sell like Run CNC, right? So there's something about maybe the cat gifs are very unserious, but there's something that's, between this like very serious, cold, closed cubicles, greasy, disconnected factory floor that's like so unexplored, like or it's just like so nascent. There's so much opportunity if more companies lean into making manufacturing cool. It's not easy. I think these companies have put in a lot of effort, and I commend them for that effort.
Do you think that so rather than just like enhancing existing jobs, like what type of career paths do you think agentic manufacturing, new career paths, do you think it will create on the shop floor?
I mean, there's this one other interesting statistics I'll throw out there. They did some research on this for factories that did adopt digital technology in the last 20 years. They actually saw a 2.5 times increase in workforce. There's kind of this myth that people believe that automation replaces jobs or takes jobs away. Actually, what it does is it drives more demand to these factories. Those factories expand and they require more people to do things. So I start that as a preface to answer the question that you had, Mo. I think like, again, we're still very early. Even just the digital economy, we're starting to see, emerging careers in like prompt engineering. So people whose jobs it is to like refine how the enterprise speaks to the LLM. I think in manufacturing, we're early, but if I were to take a stab at that, I think we're going to see things like, kind of like digital orchestration managers. We're going to see like cobot operators, right? So like collaborative robotics. So people who are able to like be the machine whisperer. I mean, we've always had that term, right? Even in the kind of physical, like there's machine whisperers. These are people who just kind of like hit the machine in the right way, and it, the blade will spin. But that same thing applies now to these more cyber physical systems. So I think you're going to have literal machine whisperers. And people whose jobs it is to also understand the quality and the effectiveness of these more complex kind of digital cyber physical systems that we have.
So go ahead, Rob.
Oh no, I would just say that the kind of how I would answer that, I'll just do it quickly because I don't have much new to say. But I think that the biggest thing that's kind of parallel to that question, I think the barrier to entry of jobs really goes down a lot, which I think is like the really cool thing. I gave the examples already of someone who was working at Home Depot and 6 months later is running a $1 million machine. I think that's a pretty crazy leap. That's able to happen that we haven't seen before, which is really cool. I also think that I totally agree with Crown what he's saying there, and I also think that it lends this opportunity for people that are maybe conventionally like a manufacturing engineer to start having more kind of commercial facing roles to help really be able to create the data sets and the processes that are feeding into the AI systems and such for that downstream processes to work well. So I see a lot of that at Hadrian where people who were engineers are now doing more business type things, which I think is really, really beneficial for us and interesting. So I think it's a lot like there's new careers that open. Yeah, I think there's also ways that people can adjust their careers a bit differently, which is really cool. And there's a lot lower barriers to entry.
So just two questions here as we close. So question one, so like 5 years from now, do you think we'll kind of point back to this moment today and say like this is when US manufacturing really changed? Or are we not quite there yet? Like, what do you think about that?
I can start just to go quick. I mean, I think that there's two things that like are top of mind for me. Like I think that there's things that we look at, and I'll just use kind of a case study of it, where you look at like commercial aviation, specifically aftermarket parts are really booming. The reason for that is because it takes an airline over 10 years to get a new part, a new plane right now, right? And so that means we have to take care of aging aircraft, which means we need more aftermarket parts, which then means we have a supply and demand problem. Prices are really high and the market is wild. You might have to wait a year for an aftermarket part, things like that. So I think that we will see quickly once you get shops that I see a lot of shops running at sub 40% utilization across programming, spindle, inspection. If you get that into the more elite status now of consistently in the between 70 to 80%, you have a lot higher of supply, which I think we'll see reduction of both costs and lead times, which would be really great. I think probably even more impactful in 5 years, if all of your smartest friends are working in manufacturing or trying to figure out how, I think that's the big telltale sign that we're treating this seriously and we're going to have that level of dominance again in the sector.
Yeah.
So then,
go ahead.
No,
go ahead. I was, if I could just like, I think as you asked that question, Mo, a lot of like startup lingo came up, like, the dots only connect when you look back. So I hope so. They also say that the days are long, but the decades are short, right? So I think a lot will happen in the next 5 years. A lot has happened in the last 5 years, right? And when it comes to the world, geopolitics, and manufacturing especially. But yes, I think so, Mo. I think we're going to look back 5 years and realize that this is the moment that 5 years since a global pandemic showed all the cracks in an overly globalized supply chain, leading to a lot of regulatory changes that were bipartisan, right? From the IRA to what we're seeing, CHIPS Act to just some of the shifts even more recently. That like this is the moment when there was a generational turnover of a workforce that led to new fresh perspectives, bringing the technology of today into the problems of today that leapfrog this entire paradigm, right? So yeah, I'm pretty optimistic. Otherwise, I wake up every day and do the grind as it goes. This is a hard industry to be operating in. There's a lot of work that needs to be done. But yeah, I'm very optimistic about it.
Amazing. Well, thank you. And you also, I don't have to ask my last question, so thank you for that optimistic take. All right. Well, look, thank you guys for being here. I know we're just at time. This was an awesome conversation. For those in the audience, this is going to be recorded, so you'll be able to go back and play this, play it back, and obviously these guys are available for any questions or comments after the fact. And then, Karan and First Residence, thank you guys for partnering with us on this one. So until next time, everyone, have a great day.